Okay, everybody, let's start with an anterior view of our skull here. Um, Here, right off the bat, you can see several bones of the face. Let's start with the mandible, okay? So we can just detach the mandible here for the moment. So if we look here, we can see the large portion of the bone, which is what I'm holding right now, which is the body of the mandible. And then here and here we have what are considered branches off of that mandible. So these would be the ramus. Each one would be a ramus of the mandible. And then back here we have the angle, which is basically the turn to go up to the ramus. Now, part of each ramus, you'll see this pointy part in front, which is the coronoid process. Think of a king's crown, corona, coronoid. And then we have the rounded portion back here, which articulates with the rest of the skull. This is called the mandibular condyle. Condyles are smooth, rounded, articular surfaces like this. Now, here in the front, we see a foramen. A foramen is simply a hole. Nerves and blood vessels pass through. We can see a foramen on both sides of the mandible here. And then we can also see ridges, and behind which there are sockets for the teeth. This ridge is called the alveolar margin, and the processes extend up between each of these teeth. All right, so that's the mandible. We attach the mandible here back to the skull, and we can take a look at some of the other facial bones. First of all, above the mandible, we have another set of teeth, of course, that are attached to a completely different bone called the maxilla. Maxillary bone is another name for the maxilla, and there are actually two maxilla bones. This ridge again is called an alveolar margin, with alveolar processes extending between those teeth. You also notice more foramen up this way, and here we have a foramen on each side, which is below the orbit. So the orbit is where your eye sockets are. These would be underneath, inferior to that orbit. And so what we do is we talk about these as being infra-orbital foramen. Infra stands for inferior in this case, okay? And there is a space inside both of these maxilla bones that you cannot see, but it is called the maxillary sinus in each case. Okay? All right. If we now turn our attention to this bone above the orbit, we see that there are two little indents here. These notches sometimes form an actual hole, so each one would be called a foramen. In this particular case, supraorbital notches are what we see. So these would be either supraorbital foramen or supraorbital notch, like this particular skull has. Now this is, of course, the frontal bone here, and within the frontal bone there are sinuses. They would be known as frontal sinuses. Now let's turn this just a bit here so we get our lateral view of the skull again. One of the things that you can see right off the bat is that there are several sutures holding together many of the larger bones of the cranium. Okay, we see one here that is known as the squamous suture. Squamous, as in squamous, like the thin cells we've seen. This is one of the thinner portions of the skull, which is why people worry when you get hit in the temple area like this. Okay, let's for a moment focus on the temporal bone. The temporal bone has many processes. Here we see the mastoid process. We have a smaller, thinner structure that extends down from the temporal bone called the styloid process. And then we have this structure here, which is going forward to touch the zygomatic bone. We refer to this, therefore, as the zygomatic process of this temporal bone. And this is a convention you see all over the skull. We call this process for what it's touching. In fact, the zygomatic bone has a portion here which extends backward to touch the temporal bone, so we call this the temporal process of the zygomatic bone. This entire structure is known as the zygomatic arch. Now there is another opening here that's part of the temporal bone. This actually goes to where your ear is, into the middle, and finally into the inner ear. This is the external acoustic meatus, or sometimes you hear external auditory meatus. Now just in front of the temporal bone here, we have the sphenoid bone. The sphenoid bone can be seen from many angles. Let's turn this now and take a look at the top of the skull. Right now we have a superior view. We can see that there is a suture that runs right down the middle. This suture would be the sagittal suture. Makes sense, as in a sagittal plane that would go in this direction. We have the frontal bone articulating with the two parietal bones here, where we see the coronal suture. Again, coronal goes along with the coronal plane, or think coronation, which is where that crown might sit. We move to a slightly more posterior view, and we see that the parietal bones also articulate with the occipital bone here. This occipital bone forms kind of an upside down V shape articulation with the parietal bones, as you might think of a capital Greek letter lambda sign that would also be an upside down V like this. Now, many times you will see small bones that are trapped in either the sagittal or the lambdoid sutures. Here in this view, you can't really see anything as such, though when I turn the skull slightly like this, I can see a little tiny bone here. This would be called a suture bone, or in your book, they say sutural bone. All right, guys, now let's turn this so that we're taking a more inferior view of the skull. All right. Just to get our bearings here, these are the teeth on the maxilla bone again. This portion here, this part is the front part of your hard palate. These are still part of the maxilla bone. But if we were to look a little more carefully here, we would see that behind the maxilla bone there are two bones known as palatine bones. These, just think your hard palate, right? These come together with the maxilla bones to form that hard palate. Now, if we turn this just slightly, we would find again the vomer bone that extends back, and then we'd find these two plates on either side of that vomer bone. This structure is known as the pterygoid process, and this structure is the other pterygoid process. A student of mine used to think these look like hard-shell tacos behind the teeth. Whatever helps you remember it. If we move back from here, we would find again the occipital bone. This occipital bone extends all the way underneath the skull, all the way back. We see the mastoid processes of the temporal bone again. And of course, there's this large hole here, the foramen magnum, for large, right? This is the largest foramen, allowing the spinal cord to pass through. On either side of the foramen magnum, we can see the rounded articular surfaces again. Here, these are again condyles, but they're part of the occipital bone, so we call these occipital condyles. They fit perfectly with the top vertebra of your vertebral column. All right, so now let's turn the skull so we have again a superior view. What we're going to do is we're going to take the skull cap right off here, and we're going to look inside at the cranial floor. The cranial floor has kind of three major portions that dip down in. We have the anterior portion. These depressions would be the anterior fossa. We have the middle cranial fossa, and we have the posterior cranial fossa. Now, if we look at the anterior portion, most of this is made of the frontal bone. But then in the middle here, we have a couple structures that do not belong to the frontal bone. Again, if we were to turn the skull, and we keep in mind that the ethmoid bone is pretty much everything between the pads of my fingers, if I hold the eye sockets like so, there are actually two structures on the inside that are portions of that ethmoid bone. We have kind of a pointy structure that sticks up here called the crista galli. And then we have depressions on either side. Here it's kind of hard to tell, but they would have very small foramina, little tiny holes. This is called the cribriform plate, through which nerves for smell pass. Now if we move back again to this middle cranial fossa, much of this is made of the sphenoid bone, with a portion in the back taken up by the temporal bone. This portion in the middle here, if you use your imagination just a little bit, looks like a little saddle. In fact, it was named for this fact. Sella turcica stands for Turkish saddle in Italian. And in front of this, you can see two openings for the optic nerves to pass. In fact, if I go and find that opening from the front, you can see that indeed the optic nerve would pass to the eye sockets, to the back of the eyeball. Now, back here we have the ridge that marks the separation between the middle and the posterior cranial fossa. This is all temporal bone. It looks like kind of a rocky mountain ridge, and in fact it's called petrous part or petrous process. Petrous meaning rocky. All right, last but not least, we'll take a look at the soft spots of the skull. This is a model of a fetal skull at approximately 32 weeks. And it's very easy to remember the soft spots if you know your directional terms. I see this is the front of the skull, the back of the skull. We have anterior used for the front of the skull. We would have an anterior fontanelle, therefore. This is the last fontanelle to go away. And in the back, we would have a posterior fontanelle. that would be kind of kitty-corner to the parietal bones and the occipital bone. Now, you can also call these the frontal fontanelle, since this anterior fontanelle is also right next to the frontal bones, and the occipital fontanelle, since this particular soft spot is above the occipital bone. Now on the side, we have two sets of fontanelles, one set that is towards the front on both sides, and one set that is towards the back on both sides. Now if we take a little closer look at these, you can see that the posterior set is right behind the temporal bone, and the anterior set are right in front of the temporal bone where the sphenoid bone happens to be. And you can see this when you take a look at the actual adult skull as well, the fact that there is in fact the sphenoid bone here, and then in the back the mastoid process of the temporal bone. So what we do is we would say either anterolateral, front and sides, and then fontanelle, and then posterolateral fontanelles. Alternatively, you could say sphenoid fontanelle, since it's above the sphenoid bone, and mastoid fontanelle, since this is behind where the mastoid process will develop. And those are the soft spots.